This video, we will see the interview preparation for data engineer. So, the topics which we will be covering are data warehouse versus data lake versus lake house, data modeling, data governance, data security, Snowflake, CDC, Kafka, ETL versus ELT, data quality, and Databricks versus Apache Spark. We'll be covering these topics, and the format of the topics will be for each topics we will be first looking at the concept, the different terminologies, and the use cases where applicable. So first we will compare data warehouse versus data lake versus lake house. So lake house is a combination of both data warehouse and data lake. Okay. Data warehouse is majorly used for the business intelligence use cases, like where we use the reporting, the Tableau reporting, the Spotfire visualizations or MicroStrategy. So wherever there is a business intelligence use case, we look at data warehouse. Where there is a data science use case, we look at data lake. And data lake house is a combination of both. Okay, so if we now see the data types, so data warehouse are dealing with structured data types. Data lake can contain structured, semi-structured, and unstructured data types. Data storage format, so data warehouse, it will be the RDBMS databases, so it is stored in relational format. And in data lake, the data is stored as files, and data lake house is a combination of both. There are files, and on top of the files there is a metadata layer which helps us to access the files as tables. Then schema, so data warehouse has schema on write and data lake has schema on read, and as data lakehouse is a combination, it supports both. Now what is the difference between schema on write and schema on read? Okay, so when you are working with the RDBMS or database tables, when creating the table you define different properties like the data type. Say for example, we have something like, say, the age of a customer, and say the age is defined as an integer field. So we cannot store string types. So during insertion itself it will fail. So if we try to insert some string, if we try to insert some state name or country name in the age column, which is invalid, the database will not allow you to store it. Okay. Similarly, if you define a table with 4 columns, you cannot store a data for the fifth column. Some additional data you cannot store. So that is schema on write, where the schema is predefined and you can insert data only if it adheres to the schema. And when it comes to schema at read, it means the data is dumped as it comes. Okay, whatever data you get from source, you dump it. Okay, and the interpretation is done at a later phase when you want to actually use the data. At that time, you will parse it. So that is schema on read. Okay. So data warehouse terms. Okay, so these are the terminologies. So there are fact tables and dimension tables. When you speak of data warehouse, there will be fact tables and dimension tables. So fact tables are basically, fact tables gives numbers. So the first table which you are seeing here, this table, this is a fact table. Okay, so in this you will have different foreign keys. So date id is a foreign key, product id is a foreign key, customer id is a foreign key. So fact table, you will have foreign keys and you will have the numbers. So quantity, it gives the value, then total amount, it gives the value or the number. So fact tables consist of your foreign keys and the values. And dimension tables explain what those numbers mean. So here these two tables, this is one table, the product table and the customer table. So these are two dimension tables. So for a product ID, you will get the product details, and for customer ID, you will get the customer details. So these are the fact tables and the dimension tables. So when it comes to facts and dimensions, okay, so the way in which they are organized in your model, you have either star schema or snowflake schema. What happens in star schema is in there is only one fact table, and all the dimension tables are connected to the same fact table. Okay, so it's basically the fact table is at the center and the dimension tables are connected to it using foreign key references. And in snowflake schema, what happens, the dimension tables are further broken into smaller related tables. So what happens is, you already have the fact table at the center, it is connected to the dimension tables, and the dimension tables are further split up, so they are again connected to other foreign keys with other dimension tables. So here if you see, this is in a star schema, you will have it like this. You will have product ID, product name, category, and price. Okay, so this is the dimension table in a star schema. So everything corresponding to the foreign ID, product ID, it will be present in the same row. Okay, in the same table, dimension table. But in snowflake schema, that dimension is further split into two dimensions. So we have this product ID, and instead of giving the category details, we store the category ID, and we have another dimension where we give details for the category ID. So this is a snowflake schema. Now, how do you determine whether you should go with the star schema or the snowflake schema? Okay, so these are some pointers which can help you. So if the data model used mostly for reporting and dashboards, then we'll go with star schema. If we need fast performance with reporting tools like Tableau or Power BI, we'll go with star schema. And if I need to keep things simple for business users, then I will go with star schema. And when should I go with snowflake schema? If the data is highly structured and large in volume. Okay, so by the structured, it means it is in a normalized, it is highly normalized, then and the volume is high, we'll go with snowflake schema. If I want to save storage space and avoid duplication, then we'll go with snowflake schema. And if data integrity and consistency more important than query speed, then we will go with snowflake schema. Now when it comes to dimensions, we have slowly changing dimensions, or SCDs. So there are different types of slowly changing dimensions. So slowly changing dimension means the values do not change very frequently. Okay, so the change in value is very slow. Okay, you do not have a value changing every day or every week. Okay, it is very, the value rarely changes like a person's address. It will change, but it will change very rarely. It won't change every day. Okay, so now to manage these slowly changing dimensions, there are different approaches. First is type 1 approach. In type 1 approach, what happens is, we just store the latest value. We are not concerned what a value was there in the history. Whatever is the historical value, we will ignore it. We will only store the latest value. All older values get deleted. Okay, type 2, we will keep full history, and we will add two columns, start date and end date, to track the history. Okay, so in our example, in case of address, what we will do is, from 1 January 2020 to 7 June 2024, the address was this value in the row. And when we insert a new row, we will start with start date as end 8 June 2024, and end date can be a default value. It can be the highest date or it can be null value. This is type 2. In type 3, we add a new column. Okay, so we will have a current value and previous value. In the address example, we will have current address and previous address. So basically, we store one historical value. We will store a current value and one historical value in type 3 dimensions. In type 4 dimensions, what we do is, we store history in a separate table, and we have it as a change date. So in this case, what we will do is, the latest record will be present in the separate table, and we will have a archival table or a history table where we will be storing the older values for it. Okay, and this is used for performance because since historical data goes away from the main table will have less number of records and it will perform better. Okay, so this is type 4, and type 5 is, it is not very commonly used. Okay, what we do in type 5 is we are slow changing data, name or address, and fast changing attributes like preferences. Here what we will do, we have many dimensions and type 1. So if you see here in the below example, what we will do is email, we know email, option and language, they are somewhat faster changing attributes correspond compared to name and city. So what we will do is we will create a mini dimension. So this, if you see this preference key, this particular table, okay, so this is a mini dimension, and what we'll do in the main table, we will store the preference key. Okay, so here we have created a mini dimension for fast changing attributes, which is email change and language. So this is the type 5. This is not very commonly used. And type 6 is hybrid, is uses type 1, type 2, type 3. So we show current value, previous value, and we also show full history. Now there is a data mart. Okay, so what is data mart? Data mart is nothing but a small subset of a data warehouse, and it is a specific business like a marketing or sales or finance department. They will have their own part of the data warehouse. So that is the data mart. And materialized views. What are materialized views? Usually what happens if your views are very complex. Okay, this is one use case. When your views are very complex, it takes a lot of time to run. It puts a load on the database. So what you do is you run the view at regular intervals, you store the data, and whenever some reporting tool or some analyst queries the view, instead of rerunning that query, whatever data is cached or stored, that will be given as output. Okay, so those are materialized view. So performance is one aspect where we use materialized view, and another aspect is if your data is changing. Okay, so your reports, you check something in the report now, and if you check after 5 minutes, okay, it gets changed. Suppose you are showing total number of customers and you do not want that report to change frequently. So what we will do is, since you are using materialized view and you refresh the view every day, so throughout the day whoever sees the report, they will be seeing the report same values and same numbers. Okay, so that is another use case where we use materialized views. Now, data lake terms. Okay, so the previously whatever we saw were the data warehouse terms. Now in data lake, data is stored in different zones. Okay, there is a raw zone, curated zone, and landing zone. Okay, so as we saw earlier, what happens in data lake? Whatever data comes, it is dumped as it is. Okay, there is no processing or done when the data is dumped. So that data goes into the raw zone. Okay, and when we get the data, we need to do some further processing or transformation, so that it can be used for analysis, so that whatever data we have processed or whatever we have cleaned or whatever we have transformed, that goes into the curated zone. Okay, and temporarily we need to store some newly ingested data or the newly ingested files into some zone as part of intermediate processing steps, or for retaining the data until the target table is loaded. So that will go into the landing zone. So landing zone is nothing but a temporary area before your data goes from raw to curated. Whatever intermediate steps you need to apply or whatever stages you need to perform, if you store the data somewhere, you will store it in the landing area. Or suppose if your data raw may contain historical data. Okay, your raw contains historical data and you get daily files, so those files will be put into landing. So as part of your process, you will process the data, store into curated, and then the file will go from landing to raw where you store history. So that is the landing zone. Now what is data swamp? Data swamp is you have a data lake, you have a lot of data, but that is unusable. Why? Because in RTBMS, right, you have tables, you have views, you have basically metadata tables, right, where you can see what all the tables that I am having. But in data lake, that is not the case. If you do not organize, it grows rapidly and then you cannot find what you actually want to look at. So that is data swamp, where you have a lot of data, but that is poorly managed, it is disorganized. Data ingestion. Data ingestion is the process of data ingestion is nothing but you bring in the data from some other source. It can be a file, it can be some database connection. Basically, you are bringing in data from another source. That is data ingestion. Metadata catalog. Okay, so as we saw that data lake, it contains a lot of unstructured and semi-structured data. So how will you search what you want to get? How will you get that information? So you store metadata for your data, and with the metadata it becomes easier to retrieve. So very simple example is you add some tags to images. Okay, so you have images, you add person names who all is present in that image, so that if you want to search for all images with a particular person, okay, it becomes easier. Okay, so tags is one example of metadata. Similarly, you can have other metadata information as well. Now in data lake, the data is stored in object storage. Okay, so object storage, so it is similar to how we store files. There are some differences. So here you'll see what is the difference between an object store and a normal file system storage. Okay, so the very basic difference is in file you access using a path like c colon slash photo slash image dot ph, like this you will access when you are accessing on file system. But in object storage you will access using some API. You will either call HTTP or REST, and then you will access the particular object, a particular blob or particular data that you have stored. Okay, and in your file system you have limited metadata. So when you have limited metadata means you have file size, who is the owner, what are the permissions, okay, what is the file name, when was it modified, okay, all this information which you normally see. If you do ls-l, what all output you see, that is nothing but the metadata for the file. But in the object storage you can have a lot of metadata. You can add additional things like you can tag whether an object is there for development or production, who owns the object, okay, and other information, right? What does that object contains, if it is a file, how it is delimited, whether it is CSV file, TSV file, or whether it is a basically some say encoded, or it is put it into double coded strings or single quoted strings. It is an CSV with single quotes. Okay, so lot of additional information, custom metadata. We can, whatever information we want to add, we can add as a metadata. And object storage is scalable. Okay, it is highly scalable, and file storage is hard to scale with large volumes. And performance is basically our file system is optimized for small files. So whatever we run, right, we say if we have SSD or hard disk drives, if you want to run our Windows programs or applications, or if you want to access our text files, so it is optimized for that particular one file system. And object storage is optimized for large unstructured data, and usually cloud systems will use object storage. So Amazon S3 or Google Cloud Storage or Azure Blob Storage, those are nothing but the object storage. Now we saw data warehouse and data lake terms. Now we'll see the data lake house terms. So delta lake. Okay, so what is a delta lake? So as we saw earlier, data lake house is a combination of both data warehouse and data lake. It has basically features, some features of data warehouse and some features of data lake. Okay, so data lake has unstructured data. So what happens is very ACID transactions. Okay, RDMS, where are dealing with transaction systems, ACID properties are very important. Okay, to ensure that your data is trustworthy. So delta lake is a concept, okay, which allows to implement the ACID properties on top of your data lake. Okay, you have Parquet files and S3 files. So Par Parquet and S3 files in themselves, they do not support ACID properties. So you add one more layer, okay, and that layer will help to bring about the ACID properties. Okay, so it is not a new database or file format. It is a storage layer that adds ACID transactions, versioning, and schema enforcement on top of existing file formats and big data systems. So it is just a layer above the actual storage. And how it is maintained, how will we get the ACID properties is there is a underscore delta underscore log folder that is created, and it stores JSON and JSON checkpoint files, and every change to the table, okay, insert, update, and delete, it is tracked in this underscore delta underscore log folder. So it acts as a database log file. So whenever two or more processes or threads they try to do some updates on the same file, this delta log is referred. Okay. And iceberg, so delta lake is one way and iceberg is another table format which is very common nowadays. Okay, so the main difference between them, both of them basically help to perform ACID transactions on your data lake. Okay, basically your S3 storage or your Parquet files, okay, wherever you are storing it, iceberg and delta lake, both of them will help you to perform ACID transactions on top of those files. Both of them are layers. Okay, but what are the differences in them is iceberg supports Parquet, ORC, and Avro. Delta lake supports only Parquet format, and compatibility is delta lake is majorly used in Spark. It is based on Databricks. Okay, and iceberg supports Spark, Flink, Trino, Hive. So it supports a lot of different tools. And vendor neutral, iceberg is vendor neutral, and delta lake is tied to Databricks. Okay. Another term which is used in data lakehouse is time travels. Okay, so a very simple example of time travel is if in your Google Doc, whenever you upload a document in Google document, okay, if you make some change tomorrow, if you make some changes after 1 week, it allows you to go back and see the old version. Okay, so if you want to see how did my document look like 4 days ago, so whatever changes were done in those 4 days will get basically erased, or they will go away, so I can go back in time to 4 days and see how the document looked at that time. Okay, so data lakehouse, it supports your time travel. So data lake is the data lakehouse uses medallion architecture. Okay, in medallion architecture, like we had seen in data lake, we had raw layer, curated layer, and raw zone, landing zone, and curated zone. Okay, in data lakehouse we have bronze layer, silver layer, and gold layer. Raw layer is like bronze layer is raw layer, whatever data comes it is dumped as it is without any processing, without any transformations. That is the bronze layer. Silver layer, where data is filtered, it is cleaned, it is processed. Okay, so whatever basically nulls are removed, if the data types are changed, they are fixed, data is unwanted, data is removed. Okay, other cleaning processes are applied on the data and it is stored. Okay, so clarify, a clean form of your bronze data is in the silver form. And gold layer is basically it is ready to use by your data science use cases or your BI use cases. Like Lakehouse supports both. Data warehouses support business intelligence use cases. Data Lake supports data science use cases, and Data Lakehouse supports both. It is a unified. Okay, so whatever data it is ready to be consumed in either BI or your reporting or data science use cases, so those are made available in your gold layer. So basically the business ready data is aggregated, joined, and ready to use for reporting tools, that is stored in the gold layer. Now we come to data modeling. So we have already seen what is star schema and what is snowflake schema. So similar to star and schema, there is a galaxy schema. So in star and snowflake schema, you have only one fact tables. Okay, and as we saw in star schema, the same fact table is connected to multiple dimension tables. In snowflake schema, the dimension tables can be further split. They can be further connected to other dimension tables. And in galaxy schema, we have more than one fact tables. Okay, so say for example we have multiple business area, we have sales area, we have finance area, we have marketing area. So each of them will have separate fact tables, and they can share the same time. Some there will be some basically independent dimension tables which are specific to a particular area, but some of them will be shared dimension tables. So that is the galaxy schema. Normalized models, it is similar to OLTP, what we see in transaction systems. Okay, so we have 1NF, 2NF, 3NF, BCNF. So basically those normalized forms. And data vault. So data vault is another way of storing your data, where data is stored in terms of hub and spoke model. Okay, so we have hubs, we have links, and we have satellites. So we'll see in detail what is it. So here if you see, we have hub. Hub is nothing but the unique business keys. So we consider we are storing customer data, customer orders. So we will have two hubs. We will have a customer hub, we have an order hub. Customer hub will contain the customer IDs. Order hub will contain the order IDs. So basically in hub we will be storing the unique business keys. In satellite we store the description data. Okay, so in satellite what will happen? In customer satellite, all the details corresponding to the customer name, customer email, customer address, all that will be stored in the customer satellite. And in the order satellite we will contain all the order details. Okay, what is the order amount, what is the status of the order, where has it reached, so that will be stored in the order satellite. And hub and satellite are connected using links. Okay, so link is nothing but it stores relationship between hubs. How are two different hubs connected, how is the customer and order hub connected. Okay, so that basically we'll have foreign keys to customer ID and keys to order ID, that is link, customer, order. So this the advantage of this data vault data modeling is it has a strong separation of keys and descriptive data, and it lets you track history easily. And there is a flexibility to add new data elements without major redesign. So if you want to add new customers, or if you want to add new attributes to customer or new attributes to order, you can do so without impacting other parts of your design. So it helps for addition of new data elements. Okay, and it ensures data lineage and traceability for audits. Now data mesh. So data mesh is another technology, or you can say another modeling style. Okay, so you have data warehouse, you have data lake, you have data lake house. So in all three of them it focuses on centralized data. Data warehouse, the entire enterprise data, it resides in one place. Similarly data lake, it is there in one place. Okay, it is managed by one particular platform team. Rather than saying in one place, you can say it is managed by one platform team in data lake. Similarly in data lake house, it is managed by one team. There is one platform team who manages everything. But in data mesh, it is an approach to managing and scaling data in large organizations. What is an instead of centralizing all data into one big data lake or warehouse, it decentralizes data ownership in domain. So basically the sales team will manage their own data, marketing team will manage their own data, finance team will manage their own data, and there is a publishing platform. The platform will allow publishing their data with clear APIs or tables. So they will provide complete metadata. So if someone wants to use marketing data or the finance data, they can go to the platform and subscribe to the data or get the data. Okay, so other teams can easily discover, and they have metadata, so they can discover. If you want to see something about finance, then they can go to the platform and they should be able to search and get the data. Okay, so this is data mesh. Basically it is a decentralized, no one particular platform team is owning your data. Okay, so each business process or each line of business will own their own data. So data governance. Okay, so now you have the data in data lake, everything is there, but whether to how can you trust the data, how can you trust the quality of data, okay, whether it is in a good quality or whether it is reliable. So you have data governance. So data governance ensures your data is usable, trusted, secure, and compliant. Okay, so what are the major components of data governance? Data cataloging. Data cataloging, as you have seen, right? So you have a vast amounts of data. Okay, and if you do not add tags or metadata, you won't be able to search your data. So that is data cataloging. Then you have access management. So you can access who has access to what data. Okay, data lineage is how your data comes from source to target. Okay, suppose you have some data, say your transaction amount. So what is the origin of this transaction amount? How does it flow from different layers and reaches your target table? That is data lineage. Quality monitoring, you have to ensure that your data is of utmost quality. You can have data quality scores assigned to the tables or data, okay, which can let you know whether the data is of a good quality or a bad quality. You have policy enforcement. You have to enforce policies. Okay, like policies, the sensitive data should be masked. Okay, that is one of the policies. Okay, and compliance. Compliance is regulatory compliance. Okay, so different countries have their own. We have GDPR, for then we have HIPAA, then we have other industries, healthcare, insurance, okay, finance. They have their own compliance regulations. So that is also managed by data governance. So now access management, policy and compliance, they look similar. So we'll try to see how they're different. Access management, in you can see who has read access, who has write access to the table. That is nothing in very simple terms. Okay, who has read access, who has write access. That is access management. Policy enforcement, how to protect sensitive data during access. Like if you have credit card number, it should be masked. Okay, if you have sensitive information like some SSN number or any other number, how you are going to protect that information, how you are going to tokenize, how you are going to mask it. That is policy. And compliance is basically the regulatory laws and standards, okay, that need to be followed, that are mandated by different agencies, government agencies. That is compliance. So one part of when you come to governance, it also contains the metadata management. Okay, metadata management is process of organizing, storing, and using metadata to help people and systems understand, find, trust, and use the data effectively. So in metadata, these are different components. Metadata catalog. Metadata catalog is a searchable inventory of whatever data you have in your data landscape. Okay, your data warehouse or data mesh or data lakehouse, whatever information you are having, the complete inventory is available in the metadata catalog. Data lineage, as we discussed, it shows how does the data flow from SORs, okay, to the target tables. That is the data lineage. Business glossaries are the definitions for terms. Okay, glossary you define. Okay, who is the basically the CRM, the HR team. Okay, they have some particular team, particular terms they use in their data, and they will give the definition what this particular term means. Okay, so basically the process owners, they give the glossary or the definition for the terms that are used in their data. Data classification, you classify the data as personally identifiable information, confidential information, public information. That is what comes under data classification. And stewardship and governance. Stewardship is, you assign ownership. You have a table, who is the business data owner, who is the technical owner, who is the metadata librarian. Okay, so all the different people who are responsible for the data, that comes under stewardship. Okay, the two tools which are very well known for data governance are Collibra and Alation. Both of them are enterprise data governance tools. Okay, and Apache Atlas is an open source tool for data governance. Okay, so data security, when it comes to data security, the things in data warehouse or lake house, these are the different aspects that we need to consider. Authentication, authorization, the encryption. So now encryption at rest and in transit. At rest is when your data is stored in a cloud environment, that is at rest. And in transit is when you are accessing the data over your network. Okay, in transit also it should be encrypted, that is in transit. Data masking, sensitive data, personally identifiable data, that should be masked and tokenized. Row and column level security. So when you have a lake house, okay, or when you have a data warehouse, you can enforce security or access controls at row level and column level. Then auditing and monitoring, who is accessing the data, you need to monitor it, you need to log it, and you need to audit that information. And data governance, we already saw data governance and compliance. Now Snowflake. So Snowflakes, very simply, it is nothing but a data warehouse on cloud. Okay, so like you have RDMS, Oracle, Teradata, Vertica, SQL Server. Okay, on you usually use it in on-premise. So Snowflake is nothing but a database, RDBS system or a data warehouse system on cloud, very simply. Okay, but it not just support data warehouse, it also supports data lake, data sharing platform, and data application platform. And the advantage of using Snowflake is you don't have to manage the infrastructure. It's fully managed and serverless. There are no servers that you need to manage. You use the service. You just use it as a service. You don't need to manage different servers. Okay, and it separates storage and compute, so they scale independently. So within Snowflake, there are multiple components. The storage is stored as in a separate set of devices, and compute as a different set of devices. So there are three layers basically. There is a database layer, which stores data in a compressed columnar format. There is a compute layer. Okay, compute layer does all the execution part. The execution of queries using separate compute clusters is done by the compute layer. And there is a service layer. Okay, so service layer handles the metadata optimization and security. Okay, so the different terms used in Snowflake. SnowSQL is nothing but your command line CLI to interact with Snowflake. Then Snowpipe is real-time data ingestion. So Snowpipes you use if you want to ingest data, streaming data into your Snowflake from other sources. Okay, so for streaming data or real-time data, you will use the Snowpipe. Snowpark is nothing but PySpark. Similar to PySpark, we have Snowpark. Snowpark allows you to write data transformations in Python, Java or Scala, and you can write it directly inside Snowflake. Stored procedures, they are called as snowproc. So in your relational term, like you have stored procedure, in Snowflake we have snowproc. Okay, so you can write stored procedures in SQL or JavaScript. Then we have tasks. Okay, so tasks, what you can do, you can schedule your SQL scripts to call some stored procedures or execute some commands automatically at a specific time or when some event occurs. That is task. And streams, changes whenever a data changes. Okay, so you have a Snowflake table and you want streaming data to be generated when there are inserts, deletes, updates to a particular table, then you can use streams. And you can also call external APIs. So these are external functions, so you can call external APIs from within SQL. Okay, so Snow Convert. Okay, so if you want to bring your data into Snowflake from other sources like your on-premise databases or files, okay, you can use Snow Convert. So what does Snow Convert do? It is a code conversion. Snow Convert is nothing but a code conversion utility. It converts your code which currently runs on RDBMS like Oracle into a format that will work for Snowflake. So it will convert stored procedures, functions, views, DDL scripts, and ETL workflows. So the create, alter, drop statements are very uh, basically they are very accurately converted. They provide more than 90% of conversion ratio. But if you see stored procedures and functions, they are converted, but you cannot guarantee 100% or 90% plus conversion. Okay, major part of it is converted. You need some manual intervention as well. Okay, stored procedures, functions, views, simple views, they will be converted. But if you are using a lot of joins also will be converted. Okay, but complex functions within views, then those will have to be manually handled. But otherwise views are also converted very well. But stored procedures functions is something you will get the major part of conversion done, 80 to 85%, or sometimes much less than that. But others you have to do it yourself. CDC. Okay, so see, when you are ingesting your data into your warehouse or lake house or data lake, okay, there are different approaches which you can use to ingest the data. One of them is CDC, which is change data capture. Okay, so what we do is we capture the changes to data in a particular database, and those are reflected to the other database. Okay, so basically what you want to do is if some data changes in Oracle, you want to copy the updated data to some other database, then we will use CDC. So there are different types how you can capture these changes. The one is the log basis. So this is the most efficient and accurate. What we do is we read from the database transaction log, and then whenever a change is identified, it will be transferred. Okay, or an event will be generated that this has changed, what has changed. Okay, and accordingly an action can be taken. Then a trigger based, what you do is you create a trigger before insert, before update, or after insert, after update trigger you can create. And what that trigger will do, it will call some procedure which will invoke a call to basically load data into other database, say SQL server, or create some micro batch file to be processed. Okay, but these are overhead. Okay, because in log based you are not adding any load to the database, you are just reading the logs that database is already generating. But in the case of triggers, database has to handle those triggers. Okay, so it is an overhead. Table comparison, what we do is we have one table, you have a snapshot, you again compare the table with the new values. Okay, but that is not real time, and that is slow because you are comparing entire tables. And timestamp based is what we do is you have a updated timestamp column for every record, you will have updated timestamp. And what you can do is whenever a record is changed, okay, you will update the update timestamp column. And what you can do in your target database, okay, which is listening to CDC events, you will store the last processed timestamp. Okay, so whatever records have come into the source table after that last processed timestamp are the new records or updated records. Okay, so in this way we can use the timestamp based. And one of the major tools used for CDC is Oracle Golden Gate. Okay. So apart from CDC, we have other load strategies. One is full load. In what happens in full load, whatever data comes into source, it either overrides the target table or the entire data is appended to whatever is already existing. That happens in full load. In incremental load, what happens is we use the timestamps or we use IDs. So whatever data comes after that timestamp is processed. And in case of IDs, nowadays everyone is using UIDs. So this won't be a good approach. Okay, but earlier we used to use incremental IDs. Okay, so it starts at 1, it increases 2, 3, 4, 5, 6, 7, 8, 9, 10, and say you are dealing with customer data and you have already processed records till customer ID 24. So you will process record starting customer ID 25. So that is okay if your data is a centralized data, you are not using UIDs or for your. But nowadays nobody uses incremental numbers. Okay, so this incremental load timestamps, you can consider it as timestamps. So data is only the data which has changed after a particular time will be processed. In batch load, there is a data is processed in terms of batches, hourly, okay, either hourly or daily or weekly. Okay, so there is a batch, there is no real time updates to data. Okay, and micro batch is similar to batch, but instead of waiting for a day or an hour, every few minutes data will be processed. So when the volume of data is huge, then processing in batch may introduce a lot of overhead, okay, or load to the database. Or it can basically, if you want near real time data, then you'll use a micro batch load. And then is the streaming load. Streaming load is real time. Okay, data will be processed as it comes. Okay, that is a streaming data load. Or Kafka. Okay, so what is Kafka? So Kafka is a event streaming platform. Okay, so what it is used for, it is used to store, send and process streams of data, real time data. Okay, you can get the data, process data in real time. So some concepts in Kafka, the main concept is a topic. So whatever data comes, you will store it in a topic. Okay, say if you have thousands of records, each topic will have some partitions. Okay, so to achieve parallelism, okay, so what happens is that topics is divided into partitions. Say if we have 1000 records and we have 10 partitions, so there will be 100 records in each partition. And consumers will say, if there are 10 consumers, each consumer will listen to one partition. Okay, so we can have 10 consumers running in parallel processing 100 records. Okay, so this is the concept of partition. Basically it is used to achieve parallelism. A producer is some application that produces data. Consumer is an application that consumes data. Broker, so all these topics, the data, everything is stored on a broker is nothing but the server where the information is stored. Cluster is nothing but a group of brokers in a Kafka ecosystem. And other, we'll have, apart from brokers, we have Kafka Connect, we have KSQL, okay, other components as well. They form one cluster. Okay, and offset. So offset is basically the main concept used in Kafka to track how much messages have been consumed by a consumer. Okay, so each message will be given a ID. Okay, and that will be used to see, suppose uh, that is not a UID, offset is a number, it is a numerically increasing value. Okay, so you can track. So if a particular partition has messages, the last offset is 300 and your consumer has read message up to 200, so it means 100 messages are still remaining to be consumed from that particular topic. Apache Kafka is the freeware version. Okay, open source. Instead of freeware, I can call it open source. Apache Kafka is the open source version, and Confluent Kafka is the enterprise version. Okay, it supports some additional things which are required for an enterprise. Okay, so what does it suppose? It has additional components like Kafka Connect. Okay, Kafka Streams. Okay, sorry, this is not Confluent Kafka. Kafka itself has Kafka Connect and Kafka Stream. Sorry, this is not Confluent Kafka. Normal Kafka also supports Kafka Connect. Kafka Connect is used to bring data into Kafka and move data out of Kafka. Kafka Streams is nothing but your real-time data. As it comes, you can transform the data. Okay, so basically you are applying transformations on runtime data. You are processing it. A very simple example is you are getting some username, you are converting it to uppercase as part of Kafka Streams. Okay, so whenever your data comes in input, your name may be in any format, but when it comes to output, it will be in uppercase as it comes. Okay, so that is Kafka Streams. And Zookeeper is now removed. Earlier Zookeeper was there to basically it was like a metadata for the brokers which performed handshaking. Okay, but now that is removed. Now the broker themselves are capable for doing all these things. Okay, so now use cases. Why will we use Kafka? We'll use Kafka for real-time analytics as it is a streaming data. Okay, everything comes real-time. Log aggregation. So whatever data from different servers you get, you can put them in a topic and you can consume them. So for the consumer, it appears as if it is coming from a single source. Okay, then we have data pipelines. Data pipelines, you get data from one source, you put to other source, that you put to target, that particular target does some transformations, dumps the transform data, that transform data is used by third source. Okay, and then so on and so forth. You can create data pipelines. You can create event driven microservices. Okay, so what are event driven microservices is your application will respond to events when a particular event has occurred to a particular, say you get a new record in a topic, then that particular application will consume that message and it will do some processing based on that message, like debit from some debit amount from account or any other. Okay, so event driven microservices. And IoT data, so IoT data is also streaming data, sensor information, they can be streamed. Yeah. So now this is the Confluent Kafka. What additional features it provides apart from the normal, the open source Kafka, is a control center. Control center is nothing but a web UI where you can control your cluster. Okay, you have access to all the components which are available in your cluster. You can get a graphical view of the topics, the partitions, the different consumers. Okay, it is like a nice UI to operate your Kafka cluster. Schema registry. What is schema registry is, normally in Kafka, your data won't be validated against any schema. Okay. Schema registry ensures your data is valid data. It uses JSON schema or Avro schema or protobuf schemas to validate your data. So if your data is not as per a predefined schema, so schema is nothing but your just like database schema you can define. So I want four fields: a customer name, customer ID, okay, the transaction date, and you can say the date should be in this format. Okay, you can specify the rules to validate your data, and if it does not match the schema, then it won't be published. Proxy is basically to access your Kafka over your REST protocol or HTTP, Kafka over HTTP. So Confluent you can also use, or MuleSoft provides a connector. Okay, the MuleSoft program, it provides a connector to access your Kafka information over a HTTP protocol or REST proxy. Then KSQLDB. KSQLDB allows your Kafka to be accessed using SQL queries. Okay, you can write select, like you write select queries, like select something from some table, some columns. Okay, so that you can use KSQLDB. Replicator. Confluent Replicator is if you have a main Kafka cluster and for disaster recovery you have created another Kafka cluster. So Replicator will copy the data from your main cluster to the disaster recovery cluster at real time, in near real time. Okay, so that is the replicator. RBAC is role based access control. So you can define levels of access. So who has read access to a topic, who has write access to the topic. So that can be done using Confluent Kafka. And Confluent Cloud, it provides a cloud based service. Okay, you can run your cluster on cloud. So when it comes to data engineering, there are two terms which are used widely. ETL, you can either do ETL or you can use as ELT. The output is majorly same. You get some data, you process it and you dump it into target. That is ETL. Okay, what is ETL? You extract data, you transform it and you load it. And what is ELT? Is you pull the data as it is without any transformation. So if you are getting data from Oracle to SQL Server, you will read the data from Oracle, you will put it into SQL Server, and then you will apply some transformations. So that is ELT. Okay. Now the major difference in that is for ETL you require some tool, okay, like Informatica or Ab Initio to actually perform the transformation. Okay, because your transformation is not happening on source, your transformation is not happening on target. There is some third party tool, or you can say some plugin or some extra tooling that is required to do the transformation. Whereas what happens in ELT, your transformations happen directly on the target systems. You do not require any third tool apart from source and target to actually do the transformations. Okay, so traditional databases use the ETL, and the modern cloud data warehouses, they will use the ELT mechanism, and performance is limited in ETL because you are relying on some third tool to do the transformation. So if your tool is not capable enough to, so there basically your tool is not capable enough to do the transformations in parallel, okay, or high throughput you cannot achieve, then your transformation is going to take time. Okay, but in case of ELT, what happens, the transformation makes use of the data warehouse landscape, because you are in the target platform itself, you are doing the processing, which is highly scalable. Okay, your data warehouses will be highly scalable and performance systems, so you get good performance in ELT. So ELT is often real time and ETL is batch based. Okay, so because you schedule a jobs to read the data, process it and put it into output, so it is a batch based. And in case of ELT, you also have raw data information, because you are first doing the load and then you are transforming it. So both the source data is also available and transform data is also available. Whereas in case of ETL, what happens is the actual source data is not dumped into the target. Source data remains in source. It is used temporarily by the transformation tool like Informatica or Ab Initio. It does the transformation and only the output is dumped into the target. Data quality. Okay, so when it comes to data quality for your data warehouse, you need to consider these dimensions. First is what? Accuracy. Is your data accurate? Then there is a completeness. Okay, so whether all the required fields are present, and there is a consistency. Okay, so now these are two terms. Okay, so these are a bit confusing, let me explain. One is consistency and one is conformity. Okay, so consistency is what? Consistency majorly comes into play when you're working with joins. Okay, so say you're joining two different tables and both the tables have a country code. Okay, both the tables have a country code in them. In one table you are storing the country code as USA, and in the second table you are storing it as United States. Okay, in that case the join won't work. Okay, so that is consistency. And conformity is what? Conformity is you define some standards. My data should be in this format and all the processes should follow that format. Say for example, if you have a very simple example, say you have some contact number, okay, and you want to store it as 3 digits hyphen 3 digits hyphen 4 digits. Okay, that is conformity. You define some standard that this data should be stored in this format, that is conformity. Then timeliness is your data should not be stale data. Okay, you should not say for example you are getting customer address and you are not updating that for say months or weeks, that your process has failed, it is not updating the data. So what you will get? You will get the in inaccurate data. And what is the reason for that inaccurate data? Because the data is stale, it is older data, it is not up to date. So timeliness is also important. Validity is it should match the format type or range. Say for example, if you have something like age of customer and you are getting some state name in that, that is invalid. So the formats and the ranges, everything should be proper. Uniqueness, you should not have duplicate data. Duplicate data should not be there because it creates problem in case of aggregation. If you are doing, say, if you have duplicate data and you are doing sum of that value, then you will not get the correct results. And lineage and traceability is you should know where your data is coming from. Okay, so if I have a target table in which there is some field, say address, I should be able to trace to the source, where is this data coming from, what is the source of this data. And if it comes in multiple layers, okay, multiple steps of processing have happened, 2 3 processes are updating that particular table and getting the target data, then we should have the entire flow, how the data is getting transformed when it comes from source to the target, what are different transformation rules that are applied. So now Apache Spark versus Databricks. So both of them are used for your data transformations. Okay, Apache Spark is also used for data transformation. Databricks is also used for transformations, and your Spark code runs in Databricks. Okay, so Apache Spark is nothing but basically open source, and Databricks you can consider it as an enterprise, as a service. Databricks is something which is provided as a service. Okay, so the ad hoc BI dashboards, if you want to run, right? If you want to run ad hoc reports, you cannot run in ad hoc Apache Spark. Okay, ad hoc reports, BI dashboards, what they do, they run query. Okay, so your Apache Spark will actually, Spark in itself will not store any data. Okay, it will do the transformation and it will store into your HDFS, or it will store it into some other place, it will store. It itself, it does not store. But in Databricks, you can also basically query the data using notebooks and SQL. And as it is enterprise wide, it provides enterprise security governance. So the major difference you can see is enterprise level only. If you want to use enterprise level, you will go with Databricks because it provides all the different controls, the security and governance. Now the PySpark, the last item in our this particular part is the PySpark terms. So RDDs are nothing but the core of PySpark. Okay, so the resilient distributed data sets are nothing but the core of PySpark. This is how the PySpark internally stores data, and that is a low level API. And data frames is a high level API which is on top of RDDs, so that it becomes easier for the developer to perform any transformations. Okay. Spark context and Spark sessions. Basically, these are the different ways which you can access your Spark functionality. Okay, they are entry points. These are basically entry points. Earlier we use Spark context, now we use Spark session. Spark session also allows you to write SQL queries, Spark SQL. Okay, you can write Spark SQL queries. Transformations and actions. Okay, so every what you can say, every method on a Spark data frame, it can be either a transformation or an action. So Spark uses the concept of lazy evaluation. So what is lazy evaluation is, suppose you are applying 10 transformations on a data. Okay, you basically you are getting a data with the customer details. You are converting the name to uppercase. You are splitting it by comma. First name and last name you are getting. Then last name you are converting to lowercase. Okay, some uh, trivial example we'll take, but you are nowhere using that particular one, the output data set. Okay, then what is the use of actually doing all those processing? Okay, so what does Spark does? Spark does lazy evaluation. Your transformations are executed only if it is required. Okay, so and when you say how it is required, it is an action step. Okay, what is action step? Action step is basically you put it into some file, okay, or you get the count. Okay, those are action steps. Or you group by and get the count, group by state and you get the count. Okay, so that those are your action steps. And your transformation steps are what? In transformation, you do some select, you filter data, okay, you map the data, you convert to uppercase or lowercase. Those are all your transformations. And actions are where you actually your code gets executed. That is the action step. Okay. Partitions. So in RDDs, your data is divided into partitions, and there are drivers and executors. So driver is where your main program runs, your main function where it runs, that is a driver. And executor is nothing but a cluster of nodes, okay, where your RDDs get distributed and your Spark code runs. Okay, so Spark executors you can consider they are nothing but your compute nodes. Okay, those are the executors. And shuffle you will, when you're dealing with Spark, you'll read a lot about shuffles are basically you have to your RDDs get redistributed. Okay, when there is a shuffle, your data frames get redistributed. Okay, and these are very expensive operations because it involves a lot of network movement. So that is the expensive operations. Okay, and Catalyst optimizer. So Spark query SQL queries, right? Spark SQL queries, they're optimized using the Catalyst optimizer. So it is optimized for the common things like joins. Okay, so your joins are very fast. You can get good performance similar to or better than RDBMS in Spark. But few things like union, they are not optimized by the Catalyst. So you have to be very careful. Okay, when you're writing your Spark queries. So this concludes